Lightweight, portable, innovative. TESCO's 6330 meter site analyzer is the most versatile and complete tool for testing the entire functionality of transformer-rated metering installations. Contact us today for a free demo. Excellent. Good morning, everybody. Happy TESCO Tuesday. Welcome aboard to our final session of this year, but don't be sad. We have some new sessions coming at you. We'll have some more information at the end of this session to tell you guys. So we have some exciting things coming up for next year, and we have exciting things to talk about today. We're going to talk about streetlight metering, and I have John Williams on the line here. John, can you hear me? I think you might be muted, John. Are you there?
Yes, I can.
There he is,
yes,
Mr. Mr. John Williams himself, who has worked on streetlight metering for quite some time and worked on many projects for us. I'm going to let you take it over from here. And as always, you guys, there's a little chat box on the bottom right-hand side. You can see that in there. I'm going to give a good morning shout to you guys. And if you have any questions, you can always throw them down there in that chat. We'll try to get to them throughout the presentation. I'll just go ahead and interrupt John anytime you guys have a question, and certainly at the end we can do a Q&A, and I'll let you take it over from there, John.
Okay, thanks, Andy. And again, welcome everybody. As Andy mentioned, my name is John Williams. I've been working with TESCO for about 17 years. In the metering and metering testing areas. And about 3 or 4 years ago, I started working with streetlight systems and sensors. Did some projects with a number of utilities in testing and developing test plans for the network lighting controllers. And we've also come up with a number of products here at TESCO using that background that we've had in testing with a couple of the utilities, and I'll discuss that in a little bit. But today's discussion is about the leveraging of streetlight metering for utilities, and kind of sharing some of the experiences that I've had in dealing with different utilities and their applications, and some of their trial runs that they've been doing, especially recently. So I will start. Hopefully, everybody can see the screen, right? I guess that's a yes.
Yep, I can see it.
Okay, great.
You're good.
Okay. So again, this presentation in particular, we're going to talk about how communication devices are being metered on smart poles, and how you can use your streetlight poles to maximize some of the revenue. We can, if you'd like, touch on some other smart city type elements that might be mounted to poles, and other equipment that might be mounted to poles that could also help with revenue generation for the utilities. But in this particular presentation, we'll talk about specifically some of the communications devices. So let's get back here. So let's start off first. The devices that we're talking about that are currently being used for or introduced as metering components for streetlight pole mounting are now called network lighting controllers, or NLCs. That is the most commonly used term for these devices. Originally, they were they came from the standard photocell devices mounted to the tops of streetlights for day-night operation for the streetlight to save some money for the municipalities that were using these things. And then with the advent of LED street lighting, some of the NLCs became a little bit more complex, adding dimming capabilities, adding on-off capabilities. But most importantly, the key here would be for the devices to have radio communications, much like the radio communications you would have on on an AMI meter, making them easy to integrate and easier to communicate to, and being able to set different parameters on those devices to control streetlights. We've worked with a number of utilities that have used these devices for many many purposes, mainly for just controlling dimming based on traffic at certain times of days. But they've also been used for some kind of different purposes. There's like animal migration patterns and things like that that were disturbed by the LED streetlights that some folks wanted to be able to shut those lights down during these migrations, and they were easily done, right? Because now we can program these devices to do on and off controls and dimming on a regular basis, just based on some programming. After some time, these devices started to venture into metrology, right? So this is where we add metering to the mix. This is particularly important in areas where the municipalities and cities are trying to save money for street lighting. As we know, that bill for a lot of big cities and municipalities is the biggest single utility bill that they pay. So switching to LED lighting, number one, saves them on energy consumption. But number two, you add these network lighting controllers into the mix, and you can control your on-off patterns, you can control dimming patterns, and save on energy consumption that way as well. And furthermore, adding the metrology to the NLC itself gives a utility the ability to meter every single streetlight individually. This way, you can prove to your municipalities that even if you have a damaged or non-operational streetlight, at that point, now you're not getting billed for that, right? As part of a tariff calculation, if the device is not working, if it's not consuming energy, you're not charging the customer for it. So in the beginning, the manufacturers of these devices started putting the metrology in there, and again, as far as the utilities were concerned, these were still kind of considered lighting under the purview of the lighting departments at the utilities, and not necessarily the metering folks. So what ended up happening is, now once the metrology started being added to these devices, meter shops for these utilities started to get involved. And of course, as we know from the metering world, there's a lot of regulation and testing and qualification that meters have to go through, or standard revenue meters have to go through, in order to be considered valuable for the utility and able to be put out there as part of their billing systems. And the network lighting controllers hadn't really reached that level yet. So, however, in the past few years, in particular, these devices have really made great strides in becoming more and more accurate. Currently, the ANSI C136 committee, which I'm a member of, is we're working on our final reviews of the standard C13650, which is essentially for those of you familiar with the ANSI C1220, is basically the ANSI C1220 version for network lighting controllers. So we worked pretty hard on that standard, and like I said, it'll probably be coming out early next year, where we have, I think, one more session this year to review before it goes out to ballot. But essentially, what we've tried to do there is to bring these devices as close as we can in terms of required specifications as you would a standard revenue C1220 meter. There are some differences, of course. They're different packages. They have different applications. But we can go over a couple of those details in a bit. In addition, we here at TESCO at least are getting calls from a number of utilities that are running pilot programs for the distribution of these NLCs out in their territories, not just for the metering of streetlights, but for other pole-mounted types of devices. Now, this is where the utilities are starting to see a little bit more variance in things that they want to put on streetlight poles, right? On or in, actually. You know, there's the communications devices. If any of you are familiar with, you know, kind of some of the smart city initiatives that are happening around the world at this point, you know, there's all kind of different sensors and devices and whatnot that are being mounted to streetlight poles now, mainly because of the fact that infrastructure is already built up, right? So you've already got the streetlight poles out there. A number of these sensors are downward looking or listening. In the case of the devices that are listening for sound, but of course some of the cameras and other things are looking down, and you have that streetlight pole there, and they're the property of the utility. So it makes pretty good business sense that you can start mounting those devices there, and with devices like this, you can easily meter them and incorporate them into your billing system. Again, because these devices are built into some of your standard radio networks. So the typical NLC specification as they stand now, and like I said, it's advancing every day, and some of these companies that are making these devices are becoming a lot more innovative with what they're doing with them. But in general, they're mostly in the 120 volt or 240 volt range, although I've seen specifications for units that go all the way up to 480 volts, all single phase. The limitation typically on such a small device is the current range. Typically, again, at this point, we're looking at 10 amps direct measurement, right? So it's essentially, if you can think about it for the metering folks, this is essentially a 1S meter from the revenue meter side. And again, as I mentioned before, the communication protocols that are built into these devices follow all the major meter radio networks like Itron, Census, Landis, and Gear. Currently, the accuracy classes for these devices are separated into three groups. There's the 2%, the 1%, and the 0.5%. And again, depending on the idea that you're going to use these devices in a place where you may not have had metering before, you might consider a 2% accuracy class device to be much better than you know, a standard calculated tariff, for instance. So it's up to the utility at that point to determine the cost benefit to the different accuracy classes. And again, the devices that I've tested over the past couple of years as the technology has advanced, these are truly accurate devices within those specifications. The 0.5 accuracy class really is you know, I've tested them to C1220, you know, a class 10 0.5% accuracy rated device is truly falls under that category. So again, in the C136 world, you know, I was very comfortable in putting those same kind of tests you would see in C1220 into the C13650 standard, just because I knew the technology was there. And there are a number of manufacturers on that committee as much as there are utilities. So briefly on the C13650, just to give you kind of a little bit of a preview, if you haven't heard some of this before, the standard is called the Standard Energy Measurement for a Network Lighting Controller, NLC. We're scheduled to release that first quarter 2021. It was supposed to be this year, but of course, with all the goings on with COVID, we've really had to, the committee meetings have been, 30, 40, 50 people on a Zoom call, and we don't quite get through as much as one might assume we would in a personal gathering, but we're pushing our way through. We've got a lot of input from a lot of different sources. As I mentioned, not only the manufacturers of the devices, but also the utilities. We've done a lot of work with the utilities in particular that are going through pilot programs, and some of the things that they see and some of the things that they'd like to see moving forward with these devices, and the kinds of ways that they test them and apply them out into the field. Is also kind of all being brought into the standard. So once it's released, hopefully everyone will take a look at it and like what they see. It's been a lot of hard work. A couple of high points here for those of you not familiar with the network lighting controllers. Originally, these devices were just that. They were a foray into metering from an industry that wasn't necessarily familiar with the type of qualifications that we in the metering industry are used to. And one of those shortcomings originally was the optical pulses, the IR pulses being emitted from the metering device itself that are used to test that device for accuracy in standard test equipment. So the first couple of times that I had to do qualification testing on some of these devices, it was simply kind of a demand test where we would be, you supply a certain amount of energy into the device. You take a read of the watt-hour register prior to putting out the energy into the meter, and then after you're done with a certain amount of energy distribution, you stop the test and then read the meter again, and that takes quite a while, as you could imagine. It a standard test for a 120 volt 10 amp single phase meter might take up to a few hours on light load. So but now the standard will require that the device have this optical output pulse. We've even defined certain case of H values that would be adequate for the job to kind of cut down on test time. We thought that might be an added bonus. That's something that you don't see in C1220. And some other characteristics of that output pulse. We defined it to use all of the standard IR pickup devices that most meter shops have on their test boards already, right? So you'll be able to use your standard pickups and maybe have to strap them on or something like that. There's really not a feature based on the form and shape of these devices, but you'll be able to use those same pickups and be able to test these devices the same way you would basically a 1S meter. As I mentioned, the 13650 also defines all the accuracy requirements, the environmental conditions, heat and light and wind and drop and things like that. So we tried to include all of the things from C1220 that were kind of a logical application for these devices, knowing that their use case is going to be a bit different than your standard socket meter. So here we can start talking about some of these alternate use cases. So here's where some of the utilities are starting to get a little more creative. There are as we know, there are a couple of new technologies that are starting to become more and more popular, especially in the big cities. Amongst those are the EV chargers for electric vehicles. We're seeing a lot more of those. Now, EV chargers typically have a metering element within them to begin with, right? Kind of like a gas pump. You know, you have a certain amount of energy that you're sending out, and of course the charging device has to have that capability. But in a number of cases that I've been involved with, the utility says, okay, yes, we know that that metrology exists within the charger unit itself. However, that metrology inside those devices hasn't been qualified by us as we would, you know, an AMI meter or anything else. So therefore, we would rather put on our pole a device like this, so as to know that the metering device is fully qualified and accurate to their specifications. Plus, you get the added advantage, as I mentioned before, of this, you know, your standard radio communications to integrate directly into your billing system, which may or may not be the case on the EV charger equipment. Of course, in bigger cities, we're seeing distribution of Wi-Fi antennas for your internet connections. And again, those devices can go on top of the pole. They can go inside of a pole, depending on the different configurations and locations. And of course, the big one that is becoming the most popular piece of equipment strapped to poles of late is the 5G communications equipment. So the big communications companies, Verizon's, the AT&Ts of the world, are really, of course, you see the TV commercials, you know, Sprint and so forth. They're really pushing this 5G concept. They want to sell more phones. They want to get people want to have faster internet. They want to have faster communications. So this rollout in terms of technical infrastructure, these companies are becoming really aggressive in that kind of rollout, which is a good thing for utilities, because these communications companies are really, you know, they're pushing to get this stuff out. They want to build out this 5G network, and they need some place to mount these antennas, right? 5G works a bit differently than 4G or 3G or anything before it. And since the communications companies are really aggressive in this rollout, that gives the utility the advantage of, you know, maybe charging a bit more to mount these devices in there and being able to meter these devices on their poles, right? As I mentioned earlier, this is a great application because the infrastructure is already there. The poles are already on the street. The street lights are already there. The utility poles are already out there. It's a great place to be able to take a device that's got to be near ground level and strap it to a pole. And then it's up to the utility at that point to demand that each one of those devices be metered. And in particular, I've worked with Verizon and AT&T at this point, but they're more than willing to do so. You know, they're, like I said, they're so kind of hell bent on getting this rollout done. You know, they're very easily negotiated with in terms of getting these things in the right place at the right time and with the right sundry equipment around them. They're hiring contractors all over the country to do these installations for them. And we here have been getting phone calls, you know, every day for the type of equipment that we supply to help this build out. And it's really gained a lot of traction out there. as I mentioned up here, some of these devices are in a higher power range, right? So your 5G equipment, your EV chargers, your Wi-Fi antennas, you might start to pull greater than 10 amps into these devices. So where does that leave the NLC? So the NLCs typically or originally had been designed to fit on top of a streetlight, right? There's a standard ANSI connector that's used to kind of just plug in and rotate the device into the top of an LED module, and that connector assembly and the mate that's on the bottom of the NLC were designed for outdoor use, right? So these things can sit outside and easily be strapped to the side of a pole, for instance, a wood pole. They also have applicability in mounting inside of more complex metal poles, right? So this has already been part of that infrastructure and design of the NLC from its very beginning. And again, too, I have a slide up here mentioning the kind of the billing aspect of this. You know, as I mentioned earlier, as far as the lighting was concerned, you know, the move away from tariff billing is being pushed by the local communities, the cities and municipalities. They're trying to save money. You know, money's tight, especially this year with the struggles with the economy. The cities are kind of strapped for cash, and if they kind of looked at this infrastructure moving forward, they can see how much money they could save and be ready for actual billing, right? They're only paying now for what they actually use, just like anybody else would want. So, and as I mentioned, couple that with the dimming capabilities and the direct, you know, on-off capabilities for these devices. You know, the variability or the controllability, I should say, for your streetlights are kind of almost endless based on this new design. Because because of this billing requirement and you know, the desire for the municipalities to save money and for the utilities to better serve their customers, this kind of was part of the forces that pushed the NLC manufacturers to achieve that higher accuracy, to kind of start meeting with folks like us in the metering industry to make sure that they're doing it right and that it'll be accepted by the utility and it'll provide the best product for their customers. So the 5G, as I mentioned before, it's pretty hot and heavy out there. I read somewhere Verizon alone is hoping to reach 200 million customers with this 5G rollout, which is a huge undertaking, as you could imagine. Right now, they're in a number of big cities, but it's spreading fast, right? So they're coming out and they're contacting cities all over the country to start working with this technology and to assist them in properly rolling out this equipment. Again, remember, in a number of cities and areas around the country, there are, you know, restrictions on what the streetlight pole can look like, what the aesthetics of any device that's out in the public can look like. So there's some restrictions there on how much, you know, how many wires and things you can have strapped to a pole before, you know, aesthetically it starts to take away from everything else in the area around where the poles are. So there's a lot of concern for that, and they're working well with a lot of the municipalities in that area. And we've been asked to do a number of things where, you know, can we create devices that, kind of cover up the wiring or the or the devices so that it's not quite as much of an eyesore. And as I mentioned before, some of the differences for 5G is it operates on a much higher frequency, and because of that, the signals tend to travel far shorter distances, right? So, and that lends itself to having to boost power, right? So they're high power, high frequency, short distances for the signals, which means there's got to be more and more of these, they call them microcells, mounted around the area where you want to reach the customers. So again, good news for the utilities. The more of these they roll out, the more devices get metered, the more energy that's consumed. Of course, that I'm sure can it's not that simple that it's all good news, but certainly, if the power is available, certainly the more consumption, the better. And these NLC devices, again, are the perfect fit here, right? So it's all self-contained. It's a little socket device. You can strap it to the side of the pole right next to any of this equipment, and integrate it right into your billing system using the existing communications infrastructure, right? It's just a different address. It's a different device type, but it all goes into the same billing plan. So, as I mentioned before, so this device is very small. It's about the size of my daughter plays softball, so I'll say it's about the size of a softball, and it's got the watertight plug on the bottom of it, and can be mounted outside. They're designed to be mounted outside, right? So they're watertight and can resistant to sunlight and all those types of things as well. So that was all built into these devices prior to even being used as meters. But because that device is built that way, it makes it a lot more flexible in the ways that you can mount these devices and where you can put them, right? So they could be outside, they could be inside, depending on how you want to do your wiring. The other thing that part of the equipment that TESCO's patented for the mounting of these devices includes a strapping device, so that once the NLC is installed, you can strap the device in with basically a security lock, and then put a standard meter seal in there to lock the strap in place. Right, so broken straps, somebody's gotten into something that they shouldn't have. There's also, of course, in terms of security, these things are typically, 2/3 of the way up the pole, and somebody'd have to really try hard to go in and either damage or steal one of these devices. But we include that locking mechanism in our mounting products. Okay, so as I mentioned before, the high power applications, right? I talked about the 5G and the wireless and even the electric vehicle chargers. Of course, you're going to get loads that are greater than 10 amps, which, as I mentioned earlier, is the current limitation on most of these devices right now. The 5G antennas, for instance, require about 3 times the power, I read, 3 times the power of a similar 4G equipment. In addition to that, there's more of them, right? So you have to space them out a little tighter, and they're going to require a lot more energy to run. So we had to come up with a system by which you can meter more than the 10 amp rating on the device itself. In addition, some folks, depending on the types of equipment that are mounted to or inside the poles, you might have multiple devices by a single company. Let's say a Verizon, for instance, might have a 5G device inside or on a pole, and also have a wireless antenna in the same region. Well, in that case, it may not be necessary to separately meter those two devices if you're going to send the bill to, one company. These meter applications, the NLC applications here, may even require even more current, because now you're metering multiple devices through one given meter. Okay, so this lends itself to what we in the metering industry know as a transformer rated application, right? So now we have to convert the current down to a more manageable load that the meter can read and read accurately, right? So one of the pardon me, one of the systems that we came up with, a patented idea for the mounting and application of the NLC to a high power application, was to put in a single box a disconnect switch, a highly accurate instrument rated CT, and the socket and strap for the NLC, all in one small package. Now you can meter up to 60 amps or even 100 amps in future generations of it, have a fused disconnect switch, plus the CT all in one box. We've also had utilities come to us and say, look, we see that you've put this entire package together, but for our asset management, we like to keep track of our own CTs. We've also made boxes that were similar, but we didn't put the CT in there. We let the utility put their own CT in the box that they can track through their standard asset management system. Some utilities will take a device like you see here in the picture, that we have the integrated CT and everything inside the box, and consider that as the meter, right? So if you manage that asset as one meter, it makes it a little simpler, and you don't have to dive deep into the individual components within the box. But it's all up to the individual utility as far as how they want to manage that asset. But the design is there. The application is available. We've been using it in a number of different places now. So we got around that NLC limitation on current by applying a standard metering technique to do this. Now, those of us that have been around instrument rated installations know that there are some safeguards that are typically built into instrument rated installations, whereby you have either a test switch, or you have some sort of lever bypass mechanism in there to keep the metering technician safe in a case where they want to remove the meter for service or testing or whatever. In this case, we patented an idea for the safe bypass of the current transformer. So whenever you remove the NLC from this device, it will automatically shunt the CT and keep the metering technician safe upon removal of the device, and still keep the energy flowing to the devices that are being metered. So we came up with that design in collaboration with PG&E in California, and we're pretty proud of that design. As I mentioned, we've got a patent on that, and we're rolling this product out pretty much daily at this stage. In addition to that, out on our West Coast folks have been working to come up with a partnership with Talley for the distribution of all our NLC mounting boxes, both the transformer rated applications and the self-contained applications, which are a bit smaller box and a little less complicated, but technologically sound nonetheless. And so Talley is distributing these products for us, I guess pretty much nationwide at this point. I'm trying to look at our chat as I'm doing this as well. Don't see any questions, so feel free to use the chat as we mentioned. But I think I'm just about done here. So that's me. That's my email. If you didn't come up with any questions or you don't have any right now, feel free to use that email address to shoot me an email and ask some questions. A couple of the other things I'd like to mention, I kind of touched on them briefly within the context of the presentation here. We have been involved in testing and working with utilities on doing test programs, sample rollouts, mounting devices, testing systems for at least 4 or 5 years now, since they been becoming more and more popular. So we're available for anything from consulting on pilot programs to qualification testing, to regular testing of devices that are already rolled out in the field. We've consulted with even a couple of the manufacturers to work with them on the implementation of their metrology and the testing of it. And as I mentioned, we're part of the ANSI committee that's looking to create the standards that's going to regulate these devices in the future. So Andy, that's about all I have.
All right, John, thank you so much. We did actually just get a few questions in. Are you able to see the chat, John?
I am. I have a question here. Are you looking at getting this approved for use in Canada, working with Measurement Canada to get 0.5% application approved? I assume that's talking about the NLC itself. At this point, I don't know if the manufacturers are looking to move into Canada with these devices. Right now, I think we're kind of locked into getting the ANSI specification done and the ANSI standard done. But certainly, this is something that would be applicable and something we'd be looking forward to working with Measurement Canada on to get the type testing definition done, at least at first done, so that we can start rolling these devices out as meters in Canada. Hopefully that answered your question. There's, go ahead.
And I'm sure Jim McGill would have more information as well for Canada whenever that does get rolled out.
Right, absolutely. Contact Jim.
And then we have another question. Are you there, Jim?
Oh, I'm here. Yeah.
Okay.
Whenever Measurement Canada gets around to deciding what direction we're going to take with these things,
okay,
then they'll issue a paper to all the utilities. But for now, we, as always, in Canada here, wait on them.
Yeah.
All right. Thank you, Jim. And it looks like we have another question from Tamara. Are the streetlight controllers typically owned by the utility or the local government? Does utility make the decision regarding the control, or does the city?
Haha. That's a really good question. The answer is both. I worked with a particular utility in the Northeast regarding just these questions, and it's not 100% defined right now, right? Because I guess it depends on the ownership of the lighting, for instance, and who has the responsibility for. I guess in a lot of cases the lighting is owned by the municipality but maintained by the utility, and that makes it kind of a little bit of an argument there as to who controls what. I would say the most typical situation is that the NLCs are owned and installed by or can be installed by the municipalities themselves, but controlled and maintained by the utility. But I think in addition to that, the one difference here would be that I think the utilities are starting to at least look at this from the point of view that okay, you can go ahead and buy these things and meter them, and we'll integrate those meters into our system, but we as the utility have a certain standard that we work by in terms of metering accuracy and durability and so forth. So, maybe the municipalities and the local governments can purchase them and own them and control them, but the utility still has final say over the specifications for the particular device. And I think that makes some logical sense in that you don't, from a utility standpoint, you don't want, defective products or substandard products being integrated into especially something as critical as a billing system in terms of the communications and the back end work that needs to be done. So it's a really good question. I think there are still local decisions that need to be made between the utilities and the municipalities themselves, and I've seen it go both ways.
All right, thanks, John. If anyone has any other questions, feel free to throw them in the chat. If you maybe are on a call and you have a question later, you want to email us, we are certainly here to help you guys answer any questions, give you any feedback. I saw Dan had posted they were kind of doing a pilot program there. So again, a lot of you guys are out there kind of navigating this. So certainly we are here to answer any of those questions for you, to kind of be a resource for you guys. So please don't hesitate to reach out anytime for us. As far as next sessions, we are going to take a break for the holidays for a little bit, and we will begin new sessions for like the winter spring season starting January 19th and running through April 13th. So we got a long way to go. We have a lot of presentations that will be a lot more hands-on. We've got a survey that went out last week, and you guys told us you kind of want some more hands-on stuff. You want some real-world testing scenarios. We are actually going to bring them to you. Some of them will be live. We'll also have a pre-recorded class for beginners. There were some people who were kind of a beginner session. So we'll do a few of those, and everything that we have will be posted on our website at tescometering.com/TESCO Tuesdays with an S at the end. You can always go on our website and search for TESCO Tuesday. You can go on our website and search for Streetlight Metering. And hopefully you find everything you're looking for. This session's being recorded. We will post this up tomorrow. We'll send the email back out to you guys. We'll have the PDF version of the email available a little bit later today for you guys. We'll be sending out more information on registering for you guys. As always, we do this free for you guys. We missed you at all the shows this year. You're not getting those sessions at meter schools that you would be doing. We want to bring this to you. We want to be, a resource you guys can go to for that.